Hello, hello. It's a SIG Node weekly meeting. It's Tuesday, January 24th, 2023. Welcome, everybody. As regular, we want to start with acknowledging some work happening in SIG Node. So we have 14 PRs merged. Some of them related to SIG Nodes, many that are just touching SIG Node a little bit. You can review what's happening, and there are a few closed, and I think one of the closed PRs will be discussed by Jack. It's on agenda today. Yeah, if you're interested what's going on, check out these links, created PRs, also what's people creating and what kind of work is happening. It's all interesting links, and I hope it will make you feel less FOMO. First agenda item today is sidecar containers cap. I wanted to give update on working groups that we're running. There is a cap that is submitted on GitHub. You can review and give your feedback. I think overall feedback so far is very positive. We still have one unresolved naming issue that we need to solve, but other than that, feedback very positive, and I think we're on a good track going forward. I wanted to give some update what it will be. So if you, before you even start reading this cap, you know what to expect. I prepared a few slides. So sidecar containers. The pattern of sidecar was published long time ago, almost when Kubernetes started. The idea is that you run some small container alongside your regular container. It runs in the same namespace, and it's very close to what your container has. Like it has same access to similar resources. And that's how it can be useful. You can get resources, you can extract resources, and the best part, you can configure the sidecar the way you want. So you can version it the way you want, you can deploy it the way you want. So there are many benefits of having a sidecar. And sidecars are quite easy to implement on regular web services. You just run another container alongside your container, and that pretty much solves the problem.
Sergey, sorry to interrupt. I don't think we see your screen. If you can reshare it. Sorry.
Oh, okay. Thank you for saying me. What do you see?
We just see you.
I think you just reshare it.
Is the screen you see now?
No.
No, we see a black screen.
Huh. That is unfortunate. I can share the link in a meeting notes. You still see black screen?
Yeah. It states that Sergey has started screen sharing, but we don't see anything.
Okay. I don't know what to do. Never had this problem before. If I try to share my whole screen, let's make a final attempt, and if it doesn't work, it doesn't work. I can just speak through the slides. Do you see my entire screen now?
Do you have a link?
Yeah, I posted the link into meeting notes. Okay, if you want to follow along, you just click on link in the meeting notes, and you'll have a slides. I hope the sharing permissions are, yeah, everybody is editor. So yeah, pattern is well known and it works generally fine. Now going to slide number 3. This implementation of sidecars falls short on some specific scenarios. Mostly people have problems with jobs that has completion. If a job runs to completion, and it typically has restart policy on failure or never. And when main container terminates, it expects the sidecar also terminated by itself, and then pod will be completed. But sidecars generally don't know about any other container, so they don't know when to terminate. They just they typically designed as a daemons that runs forever. So to solve this problem, we need to have some built-in primitives. Today, people solving it with all sorts of hacks, but having built-in primitive would really help. Then we have a problem with service mesh. Service mesh allows you to configure your pod to have only MTLS communication, for instance. So you can have inbound and outbound traffic to be protected. Unfortunately, you cannot run service mesh during init containers runs. So you can protect everything, but you cannot protect init containers, and it's not very good from security standpoint. This is something we also wanted to solve. And general pattern when you collect logs, many log collection daemons want to be implemented as an endpoint where you send logs to. And if you implement it this way, then you cannot get logs from initialization and from pod startup or container startup. It will be much easier to implement with sidecar running very early and running through initialization stage and running through all the other container startup. So having all these problems, having sidecar pattern extremely popular, we want to solve this problem and make a built-in primitive in Kubernetes to support it. So the proposal, we go into slide 4. I see many people switched to this slide. Proposal is to have restart policy always to be applied on individual containers. In this case, you can see on the right-hand side, there is an init containers collection. It's a list today. It's ordered list. And you can define some init containers that download certificates that will be used by sidecar container. And then there is a Istio proxy that will be started up. By specifying this restart policy always in init containers collection, we will make it such that it will not be terminated till the while pod is running. So it will survive through initialization stage. It will go through all the container stage, and when all other containers are done working, they will not be restarted any longer. This container will also be terminated. This is a proposal, and it fits quite nicely to solve all the problems. At the same time, it's a very targeted and small change that doesn't introduce any new collection or anything like that. So we believe that it will be working best for most scenarios. Lastly, like if you look at the service mesh implementation on slide number 5, you will, as on previous slide, you'll probably get some certificate, maybe even using different containers. Some implementation use sidecar container itself to download certificate. Some implementation will use other containers to download certificate. But whatever way you do it, you do some pre-initialization. Then container will update this IP table for the pod. So all outbound connections and inbound connections will go through the proxy, and then we'll start the proxy to go through. And finally, when this proxy already started and it's ready to be used, you'll proceed with all other containers initialization. So if you have next pod doing some file download, this download will already be started through the proxy. And then when the regular containers start, only then you will make your sidecar containers to be ready, and all other containers at some point will become ready, and they will start receiving inbound traffic. And this inbound traffic will go through the same proxy that you started on an early stage. And finally, like if proxy fails, we will restart the proxy so it will be running. And while it will be restarting, the whole pod will be not ready because you have a readiness probe on the sidecar container, and all the inbound traffic will not be sent to your pod. Outbound traffic will fail because proxy is not running. So you will need to deal with that in your application somehow. And finally, on termination, sidecar will ignore SIG term, and it will keep running. And then when all other containers are terminated, only then sidecar will be terminated as well. Some more highlights, very interesting and very unusual for containers today. Sidecars will be restarted even during pod termination. So you have very long grace period for your pod termination. And during this long time, sidecar happen to fail, we will restart it so you don't lose connection to outside world in case of service mesh. We also will solve some score adjustment problem. Today, score is calculated based on percentage of request of a container, and sidecars are typically super small. So sidecars are often the first target for kill, and it's making pods a little bit more unstable because like you have a huge pod that requires connection, and this connection being terminated because score adjustment is so small for sidecar containers. In general, we will try our best to keep sidecars running, but we wouldn't do. I mean, we had other ideas how to do it, but all those ideas was rejected because they make sidecar containers too special, and we don't want to make them too special. Otherwise, all containers will be implemented as sidecars, and it's not the side effect we desire. Finally, I wanted to go through other scenarios for restart policy field. Since we will introduce a restart policy per container, we may use other values of restart policy going forward. And some scenarios we can implement that is not possible today is for jobs that should run once to completion. We may have some initialization that may need to be restarted. Maybe it's flaky. So this will be possible with if we will implement per container restart policy. It's not part of this cap, but it may be introduced later. And other example is job with 2 containers running with different tolerance for restart, and it also will be possible to implement. There are some requests to have this functionality, and it will be done. It can be done when we will have restart policy per container. There are some alternative was rejected. I listed it here, but you can read more details in cap that I sent before. It's slide number 8. Slide number 9. We don't want to implement, which is asked sometimes, especially for service mesh implementation, is this final scenario for service mesh when sidecar crashes. We will not provide any built-in functionality to stop other containers from running. So other containers will keep running, and they may try to do some outbound connection. We're not going to solve it with some built-in functionality, but you can work around it by implementing some funky liveness probes. So for instance, you can put a liveness probe on a regular container to point into sidecar. This way, whenever sidecar is down, regular container will also be killed alongside with sidecar. Finally, another problem we hear a lot for sidecars, but we don't plan to solve it, is security boundaries between different types of containers. We know that some people want to make sure that any app containers are not privileged, so they don't do volume mounts, don't mount the volumes and don't change IP tables. While sidecars and some installation containers can be restricted either by time or by scope, what they can do. So you can make service mesh to be able to update IP tables, but no other containers will be able to do that. We discussed this problem, and this problem sounds more spread out than just sidecars. So we're not solving it in this cap, but we can try to approach it later. And I switched to Zoom, and I see hand from Dawn. Sorry, Dawn, you may be having this hand for a long time. Please speak up.
It's okay, no problem. Actually, most of my problem you already answered, and even later. So, but one comment. I think since anyway you introduce this restart policy for the sidecar, actually in the init phase, right? So kind of recently covered this one. So it's okay. Because one of the problem we do worry about the resource, right? Because the sidecar didn't have the resource requirement and the part of the init. So I think anyway, we change this init container semantics with this restart policy, right? So I do think about you also can consider to put up the resource request there. But anyway, we changed that to semantics already, right? So if you have a container and request, because before we feel like we don't need the request, those kind of things, it's just because we already calculate the regular containers resource usage. So init container anyways, just to do the preparation, so they can reuse those pod level of the resource. And we also don't want to over over conservative, right? So like the reduce of the node resource utilization. So that's why we didn't allow you put that resource request. But now you change that semantic for this, for you can allow with this restart policy. Maybe cost user could add some, or could be also default none, but still if you need additional, just point on here. So you don't, otherwise, because we kind of heard Istio, all the sidecar is really small, but cannot guarantee. People might using this one for many other purposes. So the resource might not as small as what we understand today. But the things anyway, just along
resource
with
calculation is an important topic. We covered it in details in CAP. So we will change the formula how we will do resource calculation, and this formula is now quite complex. So it used to be I mean, not trivial, but easy to implement, and now it will be harder to implement. So because of that, we plan to expose this result of computation either as metric or some pod status. So this will be changed and updated. And also, Francesca and Swati did a good job of looking into different managers, like topology manager, CPU manager, to understand how sidecar containers resource usage will need to be accounted for by those plugins, or like not plugins, but different managers. The problem, as you said today, Don, some resources being reused from init containers by regular containers. And in this case, we also need to make sure that reuse will be properly updated. So we will not try to account for sidecar containers as for regular init containers and try to claim their those resources by regular containers.
Totally. Yeah, Alexander is right, because anyway, it's going to handle by scheduler side. Yeah. Another comment, which is my minor point at this moment, because we have to do, is just you mentioned that because we are introduced this first time this per container restart policy, right? So which is kind of the change in init container semantics become to the sidecar container, but that's also actually make the future per container restart policy actually is harder, because you need to think about this per container restart policy. You need because in the past we kind of get the one size fit all, like init container anyway, you have to start one by one because it's just do preparation and until finish, and we start the second one. So you treat this as totally separate logical, and then you are introduced of the regular containers, and then regular container, then each one you treat that logic is separate, right? So because anyway they can concurrent start, separate, restart, all those kind of things. But now you have to have the additional logical say, oh, this is in the init, so it's a static container restart policy might slightly different from the rest of the regular container. So just this is minor point because not block us, but I do think about if per container restart policy is important. Actually, this is make that is more complicated.
Yeah, and I have a section about it in CAP. We really want to scope this into implementing all the needed things for sidecar CAP. And all the future scenarios for restart policy, we kind of put on a shelf saying we want this in future, but we don't want to try to address them now. Implementing those introduce all sorts of complexity, especially for cases when you go, you change the restart policy to restart less, because then you need to remember the state. Like if this container already been run to completion or it wasn't run to completion, and this state is currently not preserved for regular containers. So that kind of complexity we want to know that it exists and put it in writing, but we don't want to address and design around it yet. But we definitely will test it extensively for sidecar scenarios. Okay. Thank you for attention. I took 20 minutes of a meeting. I hope that we will still have time for all other topics. I know we have a lot. If you have more questions, please go to CAP and review and give a feedback. Thank you.
Yeah, I think one comment I had when as we are discussing this per container restart policy, recently we were looking at, we know in resize policy, we have explicit for restart container or no restart or restart not required. Tim, I was discussing, we were discussing making that more explicit. So under resize policy, we call it restart policy for resize. And I'm wondering if having this is going to cause some confusion, and if there is a way we can make it more, we want to have one restart policy, not 2 or 3. I'll share the link on the CAP and then we can discuss this offline.
That's perfect. Thank you. Good feedback. Naming is always hard, and let's try to make it less hard on us. But good feedback. Thank you. If there are no more questions, David, do you want to go through a node lifecycle?
Yeah, sure. Yeah, thanks for the presentation. I'll definitely take a closer look at that, Cap. Yeah, for node lifecycle, so kind of wanted to share this kind of issue and kind of just get some thoughts about it, and was curious if there was any prior work done on it. So the context here is that I was chatting with Tim a little bit, and Tim filed this issue on GitHub, and we discussed it a little bit. And so the context here is basically, we have quite a good amount of work that's going on right now regarding pod lifecycle. I'm actually working on a doc that describes pod lifecycle a little bit more, and we were having some discussions last week with Clayton and other folks about some improvements in this area. But one of the things we haven't really looked at too much is node lifecycle yet. The context here is that node lifecycle isn't really well documented around how different components in Kubernetes should react when nodes come and go. So a good example to explain this is, for example, if the cloud provider, for example, spins up some resources that are needed, and prior to the node being deleted, the other resources need to be deleted. So there's a little bit of dependency there. There's no real way in Kubernetes to signal, like the node is about to be deleted. So cluster autoscaler, for example, it has a specific taint that it applies on the node, and then it says like this node is going to be deleted. But that's kind of very specific to cluster autoscaler, and it's not like a standardized taint. And if other components want to implement it, they would have to use their own taint. So kind of what Tim kind of proposed in this issue is maybe we need to kind of standardize a little bit what is the node lifecycle, and specifically the termination phase of it. So for example, for other Kubernetes objects, right, there's finalizers, and that's kind of the standard way to block deletion of resources if there's some other dependent resources. So maybe we could do something like, we could put finalizers on the node object, and we would document that, if there's finalizers on the node object, the other components shouldn't delete the underlying VM, for example, right? Something like that. So this is kind of just, I'm curious to see if there's any work done on this topic, or if anyone else has kind of issues that are in this area that would require kind of documenting the node lifecycle a little bit, and specifically the termination phase, to make it a little bit more standardized across components.
David, we might have several docs in the past, both in the open source and also GKE. Some of those might be not up to date. So reach out to Nanto, and so we do have some things, and we might help you. Yeah, but this is good idea, because I remember this topic come up last year sometimes, and we do suggest people document that one, have the new document up to date. And I didn't see people doing this, so I think this is good to start.
Okay, cool. I can reach out to Lance to see if there's any prior work on this, because I'd imagine this probably came up before somewhere in some discussion. Okay, I can reach out to see what's done, and I think the outcome here is maybe eventually we would try to write this up somewhere and kind of standardize it so that other components could follow some existing model instead of having like a taint per component that no one else would know.
Yeah, it makes sense. It may also make sense, I think, to integrate this in more of a bidirectional plug eventing. How we're doing the events that are coming upstream into kubelet. I could definitely see some downstream events too coming in, so that we would know better to shut down than just you telling us to close all the pods. I mean, we can take that hint, but it would probably be better if we knew that it was going to happen. Same thing on kubelet reboot, right?
Yeah, exactly. I think some of those things are a little bit missing today, like a good signal, especially if there's other resources, other controllers that need to be watching and doing some type of cleanup in reaction to this, especially if it's prior to the deletion instead of after the deletion.
Yeah, exactly. So. And Don's right. Lantau's the right guy. If you can bring maybe Lantau, me, Peter, Renal, a few other guys that might be interested in the space, it'd be fun to discuss.
Okay, cool. We'll do.
Also, a question on Slack just a couple of days ago about one of the taints that we implement. The stain is used for post VMs that are not killed, but they're still around, but not running. So that may be also interesting discussion. And I think restarts. I remember adding documentation about like node with the same name appearing after some time that we try to treat it as the same node, but then it's not the same. So that may be also part of the discussion.
Yeah, definitely. That's a good point. Okay, cool. I'll reach out to Lantau and maybe try to get some folks together after I get some more info. Thanks all for the feedback. Cool.
Okay, next one is, I'm sorry, Asir.
Yeah, that's right. That's me. So what we've been thinking about how to improve container security, specifically how to detect containers where files have been modified or containers that have been compromised somehow. We've looked at the IMA resources that are available in the Linux kernel, the integrity measurement architecture. We are moving, well, some colleagues of mine are working on a Linux kernel patches that will allow to use IMA convenience inside the containers. So we could actually check whether containers, files inside containers have been modified or not. The end goal is to push this into the entire Kubernetes stack. So to change maybe the pod security context, CRI. We are also talking to the open community to try to push changes as well, so they can add. So in a nutshell, the whole idea is to understand that when you spawn a container, it creates a number of namespaces in Linux. We want to add a new namespace that we call it IMA namespace that will help us detect file changes inside containers, and eventually Kubernetes be able to detect when a container has been compromised. We filled an issue on a pull request for a cat. I just want to know maybe your thoughts, whether this is a feature that is needed or it's worth investigating.
I took a quick look as here, and it looks like we need to work our way up the stack, right? Like my first question is like, I went and took a look at the OCI runtime spec request, and it was in draft status because the Linux kernel changes aren't merged. So are the kernel changes merged first, then we can do the spec, then run C, and then start making opening a KEP here. Yeah.
Right. So we basically the IMA namespace is not merged still into Linux kernel. We are working on merging it. We expect to be merged maybe in a few iterations, maybe a few months. We felt an issue also with RunC, and the maintainers in RunC told us that, okay, we will not merge now anything, even the OCI specifications, because we don't have support in the Linux kernel yet. But we are working just in every part of the stack. On RunC, we are working on the Linux kernel, and we want to know whether, what you think about this feature, if it's worth integrating it in Kubernetes.
It definitely sounds interesting to me. That said, it seems a bit premature to already like have a KEP, given that we need to get the kernel changes merged and get some kind of POC running with RunC or any other container runtime. That's my take. I don't know, like Dawn, what do you feel?
I totally agree with. I feel like we definitely want to support if the RunC and the container runtime have this feature, right? So which is mean like the kernel support this feature, right? So once that is ready, because once then definitely Kubernetes is ready to support the.
Okay.
But now is a little bit earlier. You need maybe like the kernel merge, and at least you can try to do some POC, right? On a single node, you do see that naming space work well with the RunC and the container runtime, right? So the single node, and then come to here, and then we can talk about how Kubernetes enable this.
Okay, sounds good.
Thanks.
And that's all.
Thank you. Kevin?
So Kevin had a review for requests. I made a pass. I think it looks mostly good to me. I just had left a minor comment. So I think we should be able to close that soon.
Okay, thank you. Another Kevin for pod resource API. I think there is a conversation of having a meeting. Francesco, maybe you can talk about it.
Hello. So let me check about. No, we are we are reviewing this cap, and it's about extending for CDI, which is the DRA use cases, and from my perspective, so far so good. So the content itself looks okay to me, and I'm gonna have more comments or keep reviewing in the next days. So long story short, if there is a meeting planned, not aware about that.
Sorry, I thought about previous one about. I believe there was some discussion on Slack about updating CRI and solving the problem. Is it addressed during the in a GitHub, or there is a conversation going?
Just for completeness sake, the CRI things, I'm not up to speed. The cap about CDI for producer API is much simpler, and while meetings are always possible, I don't think we're gonna have it.
Maybe I misread something.
No, maybe I'm out to date. No problem.
Thank you. Vinay, what's happening in place pod vertical? You're muted.
Sorry about that. Yeah, the status remains unchanged as of I just rebased it and resolved a test failure from the rebase, and I think I see one more failure from GoLint CI, GoCI lint. I'll fix that today afternoon Pacific time, and we're with I'm Tim and Derek. Is Derek here? I didn't see him on the meeting.
No, he is sick.
He's sick. Okay. Yeah, we've been trying to get together. Like we just need 10 to 15 minutes, and we want to. We're syncing up offline to see which way to go. Do we want to merge the API and then follow up with the mothership PR, or Tim favors just merging the whole thing in one shot? And I'm okay with either ways. We're still in that same spot. I'll just keep the PRs ready, and then hopefully we'll be able to sync up this week. This week is a really good week for me, so we can do that. I don't have anything else to add.
Okay.
Thanks.
Going to the next item, it's me. I wanted to highlight this bug that was solved this week. It's about HTTP probes. The situation here is that if there are many HTTP probes and many containers defined, then we can run out of sockets, like not sockets. What was it? So what is happening? We open socket and there is some time frame when connection already closed, but we keep socket open for some time, and default is 60 seconds. So if we have a lot of containers with a lot of probes, then we can get hit some limits on node, and once we hit these limits on the node, then we start failing any HTTP connection. So it's kind of noisy neighbor problem on steroids that was addressed. If you're interested in details, you can read this presentation. I didn't find a recording from SIG network meeting, but maybe it will be up soon. So this was fixed. If you see any customers complaining about client timeout from HTTP probes, then you probably hitting this issue. Again, it was fixed on master, and there are some cherry picks that we're running. Hopefully, we can address this problem and have it eliminated. Any questions? Okay. Yeah, it's very unfortunate when probes are not reliable. In this case, it was a situation when HTTP probes didn't work, but exact probes did work because exact probes didn't use the same resources. So yeah, it was very unusual. And we know now that if customer has a host port and they actively using connections to many IP addresses, they also can exhaust node resources and make other pods unusable. So other pods, liveness probes can start failing because of that. So there are some limits on the node that we may hit with HTTP probes. Okay, Swati?
Hi. Yeah, so the first item that I have is it's related to topology manager GA graduation. We are close enough to the cap freeze, so I just want to raise everyone's attention and request for reviews on that. I've noticed that we haven't added milestones and leads, opt-in label, and things like that. So that was something I wanted to point out as well.
I can take a look today. Yeah.
Perfect. Thanks, Dawn. The second item I have is it's related to a device manager bug that I've been working on. So just to give a high level overview of it, there's a scenario where, if you were to restart kubelet or reboot your node, you have no control over how the pods are recovered. So your application pod, which is requesting devices, could get recovered before the device plugin pod has had a chance to register itself. And in that case, from kubelet's point of view, we are not actually returning any errors. And until the point the device plugin pod or the device plugin actually, the application pod tries to access the device, there is no error manifested. So with this PR that I have, what I'm trying to do is make sure that we are checking that the device plugin pod has registered and it's healthy. So I would really appreciate if people could take a look at this. It's a bit complicated in terms of how we reproduce this issue. And in order to do that, especially for the end-to-end tests, I had to modify the sample device plugin, which is a test plugin used for testing device plugin scenarios. So so the changes that were made to the sample device plugin was to intentionally prevent it from registering itself. So the second point that I have, it's related to sample device plugin changes, and we need to make sure that the image is promoted and it's accessible for end-to-end testing. So just as an overview for everyone, and if people have time, please take a look at this, because I know next week onwards everyone is going to get busy with gaps and stuff.
So just a quick question about that last thing you mentioned. If the device plugin is not available and the pod tries to come up, is the idea that the pod will be rejected during admission, or how does that failure handled? Okay.
Yeah, exactly. Gotcha. So what we intend to do is that if the device plugin either hasn't registered or there are no healthy devices, we manifest it as an admission failure for that pod.
Gotcha. Okay, I'll definitely take a look. This is definitely an issue we've seen, especially with like GPU devices and GPU device plugin. So thank you for tackling it.
Perfect. Thanks, David.
Okay, thank you. Marlo, do you want to get update on plugin, Kubel plugins?
Yeah, no updates since last week. And just a reminder that there's a discussion next Tuesday. We are working on further work on it. So we'll have updates at that point, including some code.
Okay, I think we can go to the next one. Pod sandbox creation. Deep.
Hello. Yeah. So this is just a quick update on the updating of the KEP to basically reflect the new condition that we introduced as an alpha, which was pod has network, like basically renaming it to something that SIG network is more aligned with, which is pod ready to start containers. So this was after a pretty long discussion with Derek and Tim, where there was some concerns about the condition being named pod has network and what other things it might imply. So I think we converged on a separate name, and basically this is just the update to the KEP. So if someone has some time to take a look, that'd be great. Thanks.
So is the idea here that pod has network is one of the conditions that tie into the union of what defines pod is ready to start containers?
No, so basically, I think initially it was suggested that let's call the condition pod has network, because that's the part in the code where that situation is basically becoming true. Right now, so I think like what we did is analyze like what would be a better name for it, because SIG network was trying to introduce this concept of multiple networks. And yes, one of the main things that they're trying to do is basically say that even though you have an IP address in the sandbox status from CRI, it does not necessarily mean that that won't change over the lifetime of the pod. So that's why they were opposed to the name. And they say, like, what is it that you're really trying to say? So basically what we're really trying to say is sandbox is ready, but there was also opposition to that. So the name we came up with is ready to start containers, basically.
Yes, it makes sense.
Yeah, makes sense based on the, but to me, pod ready to start a container is kind of superset for pod has network. Yeah. Only so the reason they think about, oh, we are kind of the too, what I should say, too generic, because and once we have the multiple network support, this is not the less streaming net. But then they propose an even more generic name, and they superset of the name. Pod is ready to start the content. Anyway, I'm not good at naming, so that's why I like everything makes sense. I will name the rule because I'm not terrible on the name. So, but I just comment on this.
Yes, yeah, this is totally a naming thing at this point.
Yeah, we spent good enough amount of hours to discuss that. So
Yep.
Yeah, it fits well with if you have to have policy-based readiness, like, okay, network A and network B or network C, if we have that condition and Kubelet wants to enforce that, or CRI wants to enforce that rather, that makes sense. Either ways.
I normally just say yes anyway, because I'm not good at name. And so I just need that. So I have to trust other people judgment. Honestly. Okay, I will take a look.
Thanks, Don. And Vinay, thanks.
Okay, we're moving on. Jack, exec probe timeout.
Hi, folks. So DIMS pinged me on an issue that Antonio was driving to remove the exec probe timeout feature gate, which was introduced, I think, in the 120 release cycle. So it's been a while. And that addressed a bug for exec probe timeouts not firing in Docker shim. So I think, Sergey, you may even remember this, like a year and a half ago, we tried to remove the feature gate, and Jordan very reasonably asked that we get some user feedback on whether that would be safe for folks, because the feature gate exists to protect back compatibility, even though backward compatible behavior was sort of buggy for Docker shim users. So fast forward to today, and Docker shim was deprecated in 124. I noticed that 123 is still getting, did it get its last patch release last week? But it's going to be end of life really soon. So I wonder if simply the removal of Docker shim from the Kubernetes ecosystem entirely gives us permission to remove the feature gate. We can go through the process of locking it to true and then waiting a few versions if we want to do that correctly.
Yeah, I don't think
Any
the problem
thoughts on this?
is to Docker shim. Problem on containerd problem still exists. It's surfaced differently, but still breaking customers when enforced. And we observed that on some scenarios that enforcing it may break customers unexpectedly. So you're referring to the situation when Docker shim used to wait till completion of exec probe and then react on the status, true or false. And
That's
containerd
right.
doesn't react on that; it just says true, even like if it false. The problem is when you enforce it, it suddenly became false, and it can start killing containers. So even though functionality is not working for containerd as expected, it's still working worse when you enforce the timeout, because it can break customer unexpectedly. And that's the biggest problem. So what we discussed is we wanted to have a plan and like help customers migrate. And I think you created this metrics for customers to understand which timeout to set. And I don't think we introduced any documents like how to help customers transition. So maybe if we can have a clear transition plan, like this is like how to detect situation, and this is how you transition, this is how you decide the timeout. Maybe if you have all the documentation in place, we can see if customers migrated.
Cool. That sounds fair to me. So I'll work on building up a set of documentation that folks can walk through, which aids them how to leverage the new metric to make their own measurements in their environment. And then I'll just submit a PR, and then I'll work during the PR process where that documentation should land in upstream Kubernetes. And then after that, we can do some sort of field work and reach out to the community, give a reasonable amount of time for folks to get exposed to this new documentation and have a chance to assess their own environment. So I'm happy to own that over the next, it'll probably take a while. So next couple of release cycles.
Thank you. I'm happy to help.
Okay, cool. Thanks.
We reached the end of the agenda. I think it will be good to remind that next Friday will be PRR, Product Readiness Review, deadline for CAPs. So if you have CAP in flight, make sure you have somebody assigned from Product Readiness Review and make them review stuff. And then a week later, there will be enhancements freeze. I think it's February 10th. So I think maybe next SIG Node meeting, now we can go through the list of CAPs.
Yeah, makes sense.
Okay. Yeah. Is there anything else on agenda? If not, then happy Tuesday, everybody, and have a good rest of your week. Bye-bye.
Thank you.
Thanks. Yeah.
Thank you.